This is another level 5 question on Boolean.org. You're asked to find the maximum value of this expression. What makes this question interesting is that it is non-symmetry. When it is non-symmetry, the maximum value is unlikely happen at x equals to y equals to z. So here's my plan. I first treat s as a fixed number, then write z in terms of x and y. After that, using Algebra-Inequality to get rid of y, then find the maximum value in the expression with x only. So here we go. So we let j to be x plus y squared. Now I'm going to treat s as a constant. Then y plus z will be equal to 1 minus x power 3. So this is a constant. I'll leave it here. And for this is x plus y squared. Z plus x will be equal to 1 minus y. So we'll settle the maximum value for this expression. In order to get the maximum value for this expression, we have to get rid of the y. It can be written as 2 of x plus 2 of y square, but with 1 over 4, and 1 minus y to the power of 4. This itself will be less than or equals to 2 of 2x plus 2y plus 4 of y minus y over 6 of them, then to the power of 6. This is so because of GM-Inequality. With this, y will be eliminated. And we have 4x plus 4 over 6 to the power of 6. And this is actually equals to 2x plus 2 over 3 to the power of 6. So from what we have here, this expression will be less than or equals to 1 over 4, 2x plus 2 over 3 to the power of 6. Now we are going to factorize the 2 out, and this will be equal to 2 to the power of 6, that is 64 over 4 it is, and what we have is x plus 1 over 3 to the power of 6. Then copy down x minus 1 over x to the power of 3. We are going to use Algebra-Inequality again, and this will be less than or equals to 1 of x plus 3 of 1 minus x plus 6 of x plus 1 over 3 over 10, because there are 10 items here, to the power of 10. The purpose that we take out the 2 here is because we are going to eliminate the x. Note that this is 1x, negative 3x, and 2x. So there are no more x here. What we left here is 3 plus 2, that is a 5. 5 over 10, that is a half. Half to the power of 10. So half to the power of 10 times 16, that will be equal to 1 over 64. From here, we get that j will be less than or equal to 1 over 64. Of course, we need to check when the equality holds. We use AMGN twice. So equality holds from here if and only if 2x plus 2y equals to 1 minus y. And from here, x equals to 1 minus x equals to x plus 1 over 3. So equality holds if and only if there are two conditions. The first condition is 2x plus 2y equals to 1 minus y. And the second condition is from here, that is x equals to 1 minus x equals to x plus 1 over 3. Now, from here, we'll get x is equal to half. Now, when x equals to half, we substitute into the first condition, then we'll get 1 plus 2y equals to 1 minus y. It means that y will equal to 0. When x equals to half y equals to 0, z will equal to a half. So it means that the value 1 over 64 is achievable if and only if x equals to half, y equals 0, and z equals to 1 over 2. And therefore, the maximum for this value will be equal to 1 over 64. After I have done this, then you actually give me an idea that I can have a better presentation that I don't need to separate into two different cases. So now I should show you a one-step solution. This one-step solution can be done if we modify a little bit on each of the terms. First of all, x I will write as 2x, x plus y I will write as 2x plus 2y, and y plus z will be 2y plus 2z. Z plus x remain the same, but these are not equal because this is some multiple of the j. We have 2 power 1, 2 power 2, and 2 power 3. So we need to 1 over 2 to power of 6. Okay, now we are ready to use AMGN one and for all. Okay, so based on AMGN inequality, this will be less than or equal to, copy down 1 over 2 to power 6. Then for this is 1 of 2x plus 2 of 2x plus 2y plus 3 of 2y plus 2z plus 4 of z plus x over, because there are 10 terms, over 10, then to the power of 10. Do some calculation, then we'll see that there are 2x, 4x, 4x. So there are total of 10x. And for y, this is 4 and this is 6. Also, there are 10y. And for z, no surprise, it is still a 10z. And we already know that x plus y plus z is equal to 1. So this is 10 times 1 over 10, that is 1. 1 to the power of 10 is still equal to 1. So this is equal to 1 over 64. Again, we need to check whether equality holds. Equality holds if and only if 2x equals to 2x plus 2y equals to 2y plus 2z equals to z plus x. From these two, we know that y is equal to 0. And because y equals 0, from these two, we know that x is equal to z. And the sum equals to 1, so it must be x equals to z equals to half. Personally, I think it's quite amazing if you can get this straightforward. As usual, I prepared something similar for you to practice. Have a good try of it, and check your answer when you're ready. With technology, say check for Wolfram alpha, we can easily check that our maximum value and the condition are indeed correct. That's all for today's lesson. I'll see you again. Bye-bye.